Okay, the fourth and final page of our reading rock layer notes. Okay, so you should be good on the law of superposition. Older rock layers on the bottom, they get younger as you go up. Extrusions are the same thing. Intrusions and faults are always younger than the layers they cut through. So remember all those things. Now, you know how when you're in language arts and they teach you these rules and then they say, well, there's always this exception to the rule and then you got to learn that too. Okay, well, there is an exception in reading rock layers, okay, but it's not something you have to learn, okay? Basically, when there's something missing from rock layers and scientists don't really know why it's missing, they call it this. This is why I love science, is they don't give you a whole bunch of stuff you have to know. They just say, okay, this is missing. We're just going to call it an unconformity, okay? So an unconformity is when there's a gap. There's something missing. They're not really sure why. They might be able to take a guess why, but they don't know for 100%. So they just call it an unconformity. So if you ever see one of those, when you're reading rock layers, you'll see like some type of something missing. You see how this layer is here, the same layer is here, but some of it's missing out of the middle. Okay, it could have been a flood, it could have been weathering, it could have been, a tornado. I don't know, but something happened and it removed part of this layer. And sometimes it'll be part of the layer, or sometimes it'll be an entire layer altogether. It just depends. But they mark it with an unconformity. So if you see that word, that's what that means. It means something is supposed to be there, but it is not there anymore. Okay? Pretty good, right? All right. The last thing that scientists use to determine relative age are these things called index fossils. Okay? Now you guys remember that trilobite I talked about? A trilobite is an example of an index fossil because it was a fossil that was widely distributed. Widely distributed means it was basically all over the entire world. Okay? And the cool thing about a trilobite is it only existed for a very brief period of time. So all of a sudden it was here, and then all of a sudden it's not here. So, and when we say a brief period of time, it was still around for a long time, but scientists can determine the relative age of things because they know exactly how long a trilobite lived. Okay, so anything that's located near a trilobite must have lived during that same period of time. Does that make sense? I hope so. I'm sure you understand. Y'all are really smart. Okay, so let's talk about how they use it. So they use these things to help determine relative age of rock layers also. So look at these index fossils down here. Now I know these are all just shapes and symbols and stuff like that. But look, let's say this is a mountain in Europe, this is a mountain in North America, and this is a mountain in South America. If the same index fossils are found in the same mountains, what does that tell you about those rock layers? That's the question I want you to answer. It says, what does that tell us about the rock layers if this star fossil was found in the same, or in this layer in South America? What does that tell you? Europe's all the way on one side and South America's all the way on the other. What does that tell you? Yeah, you would be right. I know you're right. Lily, I know you got it right. Okay, basically what that means is that this rock layer and this rock layer were formed at exactly the same time. Okay, just like this rock layer and this rock layer were formed at exactly the same time. Okay, now that's all for page 4. So I got to get off here because the announcements are coming on. So good luck. Get your practice in. I'll see you guys on Monday or Tuesday.